Imagine waking up tomorrow to a dark sky stretching across North America. Down below, commercial flights are entirely grounded. Regional power systems are failing. Millions of people are suddenly wearing masks to filter out the microscopic shards of volcanic ash choking the air. A hypothetical supereruption beneath Yellowstone National Park has triggered this continent-wide paralysis. Most people identify a volcano by a towering conical peak, like the one seen here. Yellowstone lacks this feature entirely. Yellowstone operates as a caldera, a vast underground magma system. These brilliant geothermal pools act as surface-level indicators of the intense heat system below. Scientists emphasize that a massive caldera-forming supereruption is exceedingly unlikely, with no evidence suggesting one is imminent. Future activity is more likely to resemble this geyser, a smaller hydrothermal explosion, or a localized lava flow. Running through this worst-case scenario is a useful thought experiment. Tracking a hypothetical supereruption reveals the actual vulnerabilities in modern civilization, exposing risks that high-budget disaster movies often overlook. A supereruption would be preceded by months of extreme geological warning signs. The ground above the caldera would deform rapidly, accompanied by intense and frequent earthquake swarms. Scientific agencies monitor these metrics around the OC. Detecting such anomalies would trigger regional evacuations on a scale involving millions of residents. This diagram shows the scale of the initial blast. A column of gas and pumice would rocket 30 to 50 kilometers into the stratosphere, reaching altitudes several times higher than commercial flight paths. Near the park, pyroclastic flows, rapid currents of extremely hot volcanic gas and rock, would expand outward, leveling the landscapes of Wyoming, Montana, and Idaho. Ground collapse during the eruption creates a new caldera, but this geological process is localized to the region. The eruption leaves the rest of the continent physically intact. Volcanic ash consists of jagged fragments of rock and glass. It is far more abrasive than the soft ash found in a fireplace. This map shows prevailing winds carrying that abrasive material outward. The heaviest deposits fall across the west, but winds distribute layers across the continent. As the blanket washes over cities, jagged particles clog machinery, contaminate reservoirs, and force flight hubs to close. In the regions hit with the heaviest ashfall, ground transportation grinds to an absolute halt, trapping vehicles and burying road networks in thick debris. In distant cities like New York, the primary threat is the collapse of long-distance supply chains, rather than burial under meters of volcanic rock. The supereruption reaches a planetary scale as the plume injects massive amounts of sulfur dioxide directly into the upper atmosphere. This atmospheric model illustrates the chemical shift. Sulfur dioxide converts into sulfate aerosols, acting like tiny mirrors to reflect sunlight back into space. This chart displays data from 1991, when the Mount Pinatubo eruption caused a measurable 0.7 degrees Celsius drop in global temperatures. While exact temperature changes are difficult to predict, a catastrophic Yellowstone eruption would likely trigger a temporary multi-year global cooling period. The volcano's influence ultimately extends into the atmosphere, altering global weather patterns far beyond the reach of physical ashfall. This climate shift leads to widespread agricultural disruption. Cooler temperatures, diminished sunlight, and changed rainfall patterns make it difficult to sustain global food production. Simultaneous crop failures in major growing regions would lead to severe livestock feed shortages and skyrocketing food prices, placing immense pressure on nations that rely on food imports. Humanity is likely to survive a Yellowstone eruption, relying on global trade networks, advanced technology, and inherent adaptability to weather the crisis. A Yellowstone supereruption serves as the ultimate stress test of whether our hyper-connected, precisely timed modern civilization can adapt when nature reclaims control.